According to the National Electrical Code, specifically Section 300.3b, it is permissible to run multiple conductors, encompassing both the main bonding jumper, or MBJ, and subpanel wires within the same conduit. However, there are critical stipulations that must be adhered to for safety and code compliance. The primary condition is that the conduit must be adequately sized to accommodate all of the conductors that will be contained within it. This includes not only the subpanel wires providing power to the subpanel, but also the ground wire associated with those circuits, and the main bonding jumper wire that connects the neutral busbar of the service panel to the grounding electrode system, which includes components like grounding rods and metallic water service piping. Furthermore, the total number of conductors present within the conduit must not exceed the conduit fill limitations as prescribed by the NEC. These limitations are in place to prevent overheating of the conductors due to insufficient heat dissipation, as well as to ensure that the conductors are not damaged during installation due to excessive crowding or pulling stress. To ascertain whether the existing 1.25-inch PVC conduit is suitable for accommodating the additional number 4 copper main bonding jumper wire, a detailed calculation must be performed. This calculation involves determining the total cross-sectional area of all the conductors that are planned to be installed within the conduit. This includes each of the individual insulated conductors that comprise the subpanel feeder, which typically consist of 2 ungrounded or hot conductors, 1 grounded or neutral conductor, and 1 equipment grounding conductor. Additionally, the cross-sectional area of the proposed number 4 copper main bonding jumper conductor must be included in the calculation. Once the total cross-sectional area of all the conductors is determined, it must be compared against the allowable fill capacity of a 1.25-inch PVC conduit as specified in Chapter 9, Table 4 of the National Electrical Code. This table provides the maximum allowable percentage of conduit fill based on the number of conductors contained within the conduit. It is crucial to consult the most recent edition of the NEC to ensure that the correct values are used, as these values may be subject to change from one edition to the next. If the calculation reveals that the total cross-sectional area of all the conductors exceeds the allowable fill capacity of the 1.25-inch PVC conduit, then it will be necessary to either install a larger conduit or reduce the number of conductors being run through the existing conduit. This could potentially involve running the main bonding jumper conductor through a separate conduit altogether. It is important to note that overfilling a conduit can have serious consequences, including overheating of the conductors, damage to the insulation, and even electrical fires. In addition to the conduit fill requirements, the National Electrical Code also mandates specific requirements for the insulation and sizing of the main bonding jumper conductor. Specifically, NEC Section 250.64 outlines these requirements in detail. According to this section, the main bonding jumper conductor must be insulated, and the insulation must be of a type that is approved for the location and environment in which it will be installed. This means that the insulation must be suitable for exposure to moisture, temperature variations, and any other environmental factors that may be present. Furthermore, the size of the main bonding jumper conductor must be sufficient to safely carry the maximum fault current that could potentially flow through it in the event of a ground fault. This is a critical safety consideration, as an undersized main bonding jumper conductor could overheat and potentially melt or vaporize under high fault current conditions, leading to a loss of ground connection and a significant increase in the risk of electrical shock. To determine the appropriate size of the main bonding jumper conductor, a calculation must be performed based on the size of the service entrance conductors. NEC Table 250.102. C1 provides guidance on selecting the appropriate size of the main bonding jumper based on the size of the service entrance conductors. In this particular case, the service entrance conductors are 4/0 aluminum. According to NEC Table 250.102, C1 for 4/0 aluminum service entrance conductors, the minimum size of the main bonding jumper is number 4 copper. This means that the proposed number 4 copper main bonding jumper conductor is indeed the correct size for this application, provided that it meets all other requirements of the National Electrical Code, including the insulation and conduit fill requirement. It is important to emphasize that the National Electrical Code is a comprehensive set of regulations designed to ensure the safety of electrical installations. Compliance with the NEC is not only a legal requirement in most jurisdictions, but also a critical factor in preventing electrical hazards and protecting people and property from the risk of fire and shock. Therefore, it is essential to consult the most recent edition of the NEC and to seek the advice of a qualified electrical professional whenever undertaking any electrical work. In summary, while it is generally permissible to run both the main bonding jumper and subpanel wires in the same conduit, there are several important considerations that must be taken into account. Firstly, the conduit must be properly sized to accommodate all of the conductors without exceeding the fill limitations specified in the NEC. Secondly, the main bonding jumper conductor must be insulated and sized in accordance with NEC section 250.64. By adhering to these requirements, it is possible to ensure a safe and code-compliant electrical installation. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrical professional if you have any questions or concerns. A qualified electrician will have the knowledge, skills, and experience necessary to perform the work safely and in accordance with all applicable codes and regulations.